In this video, we will specifically look at Java's exception handling mechanism. Remember that an exception is an object that represents an unexpected situation. For instance, if a file is not found or cannot be accessed for whatever reason. If that happens, an exception object is created by you or by some method that you call and then thrown. Next, the interpreter then looks for a suitable exception handler based on the type of the exception and an increasingly large call context, so ever further up the call stack until some exception handler is found. If none is found, the program will simply terminate. In fact, what happens is a big catch-all handler prints to the terminal and exits your program. Java syntax for defining exception handlers is as follows. The dangerous code is put into a block just after the keyword try. This is followed by one or more catch blocks, which are basically methods that take one exception parameter each. Eventually, there may be a finally block that gets executed in any case. The ordering of these catch blocks is actually important. The interpreter will check them one by one, top to bottom, and the first one whose parameter type matches the exception is picked. So for example, if the try block throws a Y exception, and Y exception is a subclass of X exception, then the handler in line 5 is picked and not the one in line 8. And this is because every Y exception is in particular also an X exception, so the first exception handler is picked. If you were to swap the ordering of these exception handlers, then of course the first one matching would be the one currently defined in line 8. I should also mention that the syntax for throwing exceptions is simply the keyword throw. So you can, for example, throw an exception E. If E is not yet defined, you can throw a new X exception. The designers of Java originally followed this ideal that your code should either catch its own exceptions or it should declare the possible exceptions that can be raised as part of a method's signature. And this is because that would allow static analysis at compile time. So allow the compiler to complain if your code could potentially raise some exception that isn't dealt with. And the syntax to declare that your code might throw an exception of a certain type is like this. As part of the signature of the method, for example, here you have a public string method called myMethod, you would add the keyword throws followed by the name of the exception that might be thrown. So this defines a method that can potentially throw an X exception. Because this mechanism allows the compiler to check if exceptions are raised or dealt with, this type of exception is often called a checked exception. Let me give you a first concrete example. This is a simple main method where in line 4 we read a byte from the keyboard and then we would output it to the console again. The call to system in read is potentially dangerous because that might raise an exception. And indeed, if you try to compile this, then the compiler will tell you, hang on a minute, in line 4, there's an unreported exception of type IO exception, and this must be caught or declared to be thrown. Now we have two possibilities to fix this. Either we could simply declare that also our method can raise this exception, or we deal with the exception. Let's have a look at both situations. The first and simpler case is to simply declare in the signature of our method that now our main method may throw IO exception. And this would make the code compile as expected. The alternative would be to try and catch the possible IO exception. And this would look as follows. You would add a big try block from lines 5 to 10 here that includes our dangerous line of code 7. It might also include others, as in this example. And afterwards, we define a catch block for the IO exception type. And in our case, what this simply does is it would print the stack trace. This calls a method on the exception object. Nice. The issue with all this is that declaring all possible exceptions that could be thrown in your code is very cumbersome, and people find ways to go around this by defining catch-all exception handlers. And this is, of course, totally besides the point. For this reason, the designers of the language have muddied the waters and allowed certain types of exceptions to be not declared. In fact, the hierarchy of exception classes in Java looks like this. It's defined within java.lang, and it defines the following classes which can be thrown, meaning they can be used using the keyword throw. The big superclass is throwable. From this we derive exception, and we also derive errors. Now, errors are throwables that are used for serious non-recoverable situations. For example, you reach the bound on the possible recursion depth. Exceptions are often used for recoverable situations. As I mentioned, there's this boundary between these classes where errors as well as runtime exceptions and all possible subclasses are what's called unchecked throwables. And this means that the compiler wouldn't complain if it's not checked nor dealt with. Whereas on the left-hand side of this border here, these are checked exceptions. And this means that if you have a subclass of exception that isn't a runtime exception, then the compiler will make sure that you handle or declare it. Finally, let me mention that, of course, you can define your own exceptions to represent specific error situations in your code, but consider existing ones. Java.util already defines a range of exception types for specific situations. Here's just a short list of some useful ones. Arithmetic exceptions, index out of bound exceptions, file not found exception. An interesting and quite useful one is input mismatch exception. That is appropriate if, for example, you expect a date in a certain string format and you get a string that is not in that format and therefore not parsable. So if you're tempted to define your own exception classes for your specific errors, before you do that, always have a browse around in the standard library if there isn't already an exception type that is appropriate for your use case.